Artificial variable techniques. Artificial variable techniques. As mentioned in the syllabus, we have two methods there. One is big M method, the other is two-phase method. Big M method and two-phase method. Okay. Now let us go for the big M method first. When do we get artificial variables first of all? That's the question. So let me give one simple example. Suppose x plus y greater than or equal to 10. Greater than or equal to 10. And both x and y are greater than or equal to 0. Now, in order to put this constraint expression into standard form, we have to get an equality sign. For equality sign, what we do? We subtract x plus y minus s1 equal to 10. Yeah, this is in standard form. 100% this is in standard form. No dispute on that. But to start simplex method, we need to consider since S1 also is non-negative, we need to consider initial basic feasible solution. And what is initial basic feasible solution? Quite obviously, we are going to take x equal to 0 and y equal to 0. When you take x0, y0, S1 comes out to be minus 10, which is negative, which cannot be accepted as a solution. It cannot be negative. Okay? Therefore, in all such cases, what we do is we introduce an artificial variable a1, where a1 also is greater than or equal to 0. Okay? Now, it's without this itself, it is already in the standard form. So, to get into standard form, I don't require any artificial variable. Artificial variable exists not because that we have to bring into standard form. Artificial variable exists because we have to have a valid initial basic feasible solution to start your simplex method. Keep this in your mind. I am re-emphasizing this because I know there are people who do some mistakes here, where I will tell you that later also. Okay? Artificial variable exists here. We introduce artificial variable definitely not to bring into standard form, but after getting into standard form, to start initial basic feasible solution, we require a consistent equation. We require a consistent initial basic feasible solution, therefore we consider this artificial variables. Okay, and one more thing, one important thing that you need to understand here is artificial variables are most dangerous. Okay, as long as artificial variable exists in the basis, because in the beginning it is already in the basis. In the initial basic feasible solution, what we are going to take? X equal to 0, y equal to 0, S1 equal to 0, which gives me A1 equal to 10, which will be in the basis in the initial basic feasible solution. As long as artificial variable is present in the basis, means you will not get a solution. Suppose somehow, because of some reason or the other, you got optimality, but still artificial variable exists in the basis. There is no solution for this system. No feasible solution. Are you getting what I am saying? Artificial variable most dangerous. It has to be thrown out of your system as soon as possible. It cannot exist in the system if you want a solution for the system. So artificial variables, throw them outside. When do you get a chance to throw them outside? Because if you go with the procedure will take care of it. But certain instances where you get a chance to throw it out, you can use your mind actually. You can use your common sense. How? For example, if the ratios ybj by xj greater than 0, least ratio. Suppose there are two variables for which you got least ratio. One of the variable is artificial variable, other variable is your regular variable. Then you got a chance. You got a chance. Which one has to leave the basis? Let artificial variable go out of the basis. Are you getting? So you also will get a chance. You can use your common sense to throw it out of basis. Number one, once it goes out of basis, don't allow it to re-enter. ఒక్కసారి బయటికి వెళ్తే డోర్ క్లోజ్డ్. అలా చేస్తేనే, if you do that way, then only you'll get a solution or you will not get a solution. That's the reason it's most dangerous. Throw it outside. Okay? So artificial variable most dangerous. As far as possible or as soon as possible, try to throw it away from your basis. Once it goes out of the basis, don't allow it to enter it again. So how to do that? Don't allow it to enter. So don't try to compute its net evaluations. Stop computing its net evaluations. So the doors are closed. Not only closed, it's locked also. Okay. Take this. Big M method. Big M method. What is this M all about? M is very huge, big value. That's the reason we say big M. Some big M you consider. Okay? This M in fact is a kind of a cost quotient. It's a kind of a cost quotient. You give huge value of M, some in 1 lakh, 1 crore or whatever, but huge big value of M, and give this cost quotient to artificial variables. Why we give this cost quotient to artificial variables is that we try to throw these artificial variables out of your basis as soon as possible. Therefore, we give highest cost quotient to artificial variables, that to minus M cost quotient, not even plus M. We give minus M cost quotient to all these artificial variables in the objective function. Right or not? This is also called, you should know the alternative methods, penalty method. కొన్ని సౌండ్స్ ఎక్కువ వస్తున్నాయి. ఏం సౌండ్స్ అయ్యి? This is also called as penalty method. Penalty here is the big M itself is a penalty. Okay, big M itself is a penalty here. Okay, we assign big penalties. Big penalties in brackets. You write minus M cost. Minus M cost. We assign big penalties in brackets minus M cost to all artificial variables in the objective function. To all artificial variables in the objective function. To drop them from the basis. To drop them from the basis. Next, take one more point. Whenever artificial variable leaves the basis, whenever artificial variable leaves the basis, we remove its entries in the simplex table to stop it from re-entering the basis. To stop it from re-entering the basis. Next point. If artificial variable exists in the basis, if artificial variable exists in the basis, when optimality is reached, then When do you know optimality is reached? When all net evaluations are non-negative, but still artificial variable is present in the basis, okay? When optimality is reached, then there exists no feasible solution to the problem, to the LPP. There exists no feasible solution to the LPP. Take a question. Use Big M method to solve. Use Big M method to solve. Minimize z equal to 4x1 plus 3x2 subjected to the constraints 2x1 plus x2 greater than or equal to 10 minus 3x1 plus 2x2 less than or equal to 6 x1 plus x2 greater than or equal to 6 x1 comma x2 greater than or equal to 0 greater than or equal to 0. Okay. Now, quite obviously, putting it into the standard form, okay, converting the given LPP into the standard form, maximization of z star equal to minus 4x1 minus 3x2. Some more will come, so I am stopping it here as of now for this objective function, subjected to the conditions 2x1 plus x2 chapali. Minus S1 equal to 10 plus A1 malli pedamu, okay, equal to 10 minus 3x1 plus 2x2 plus S2 equal to 6 x1 plus x2 minus S3 equal to 6 x1 comma x2 comma S1 comma S2 comma S3 non-negative. Actually, first we are trying to put it in the standard form first. So till now we don't have any issue, okay? But now to consider initial basic feasible solution, we need to go with this one. Now to consider initial basic feasible solution by what method? By Big M method. So there is another method for which we take different concept, okay? First let us put it in the standard form by introducing slack and surplus variables, okay? Right. Introducing artificial variables A1 and A2, introducing artificial variables A1 and A2 in the constraints and assigning minus m cost and assigning minus m cost to the artificial variables in the objective function by using Big M method, by using Big M method. If it is two-phase method, I will adopt a different technique, okay? Now form the simplex table, Now to form the simplex table, what would be my objective function? First of all, here this would be A1 and this would be A2 and objective function would be 0 times of S1 plus 0 times of S2 plus 0 times of S3 minus m times of A1 minus m times of A2. Actually, మీరు డైరెక్ట్ రాసేయచ్చు మళ్ళీ ఇంకోసారి ఇదంతా రాయాల్సిన అవసరం లేకుండా whatever you have written directly in which you can write them. But you just need to mention that by using Big M method, introducing artificial variables A1 and A2 and also assigning them minus m cost in the objective function. Form the simplex table. Variables ఎక్కువగా ఉన్నాయి, therefore పెద్ద table తీసుకోండి. Cj, Xb, Yb, Cb, X1, X2, S1, S2, S3, A1, A2. This is Ybj by Xj, Xj greater than 0. Okay, what is the initial basic feasible solution? First of all, X1 is minus 4, minus 3, 0, 0, 0, minus m, minus m. So, A1 equal to 10, S2 equal to 6, A2 equal to 6. Okay. Now, minus m, 0, minus m, CVs. So, 2, 1, minus 1, 0, 0, 1, 0, minus 3, 2, 0, 1, 0, 0, 0, 1, 1, 0, 0, minus 1, 0, 1. Okay, this is initial basic feasible solution. Okay, na? Now, net evaluations, delta J equal to Zj minus Cj. So, minus m into 2, minus 2m, minus m, minus 3m plus 4. Minus 3m plus 4. Next, minus 2m plus 3. S1 m, S2 0. This m ravali. This is 0, this is 0. Okay. ఇప్పుడు మీ బుర్ర ఉపయోగించి most negative net evaluation minus 3m plus 4. Suppose ఇది కూడా minus 3 ఉందండి. Minus 3m plus 4 minus 3m plus 3 then minus 3m plus 3 becomes most negative net evaluation. Okay na? Not. And the doubts vastha unte appudu clarify chesukovali మనం. So right now in this instance minus 3m plus 4 is the most negative net evaluation. The corresponding variable x1 enters the basis. Okay. Now consider the ratio to identify the variable which leaves the basis. So 10 by 2, 5. Second one I cannot do. 6 by 1 is 6. So least ratio is for A1, therefore A1 leaves the basis. Key element 2. Make that key element as 1 and the rest of the elements in that column as 0. A1 goes, x1 enters, minus 4, 0, s2, minus m, a2. 10 by 2, 5, 1 by 2, minus 1 by 2, 0, 0. Here, A1 since already left the basis, I stop computing its entries in that column. Okay. So, I will not compile its entries anymore. I stop. Okay. Next, 0 here. Make key element as 1, rest of the elements in that column at 0 means that by using elementary row operations. So, minus 2 times and add, minus 2 times and add, minus 2 times and add. Three times of this and add, okay. 5 is 15 plus 6, 21. 3 times and add, 3 by 2 plus 2, so 7 by 2. 3 times and add, minus 3 by 2, 3 times and add, 3 times and add, 0, 3 times and add, 0, okay. Minus 1 times 1, minus 1 times half, minus 1 times half, minus 1 times, minus 1 times, minus 1 times, okay. But ఎవరు సొంత వాళ్ళు చేసుకోండి ఇట్లాంటివి, ఎవరు పద్ధతి వాడితే. నన్ను చూసి ఫాలో అయినా మీరు మిస్టేక్ చేయొచ్చు, పక్కన వాళ్ళని చూస్తే ఇంకా పెద్ద మిస్టేక్ చేస్తారు. ఓకే, సరే. Delta J equal to Zj minus Cj. Net evaluations again. So this is minus m by 2 minus 2 plus 3 plus 1. Again minus m by 2 plus 2 plus 2. This is S2 unnadu kabatti 0, S3. So m అవుతాడు వీడు. ఆర్టిఫిషియల్ వేరియబుల్ ఉన్నాడు కాబట్టి 0 అవ్వాలి. ఓకే, కొన్ని కంప్యూటేషన్స్ చేయాల్సిన అవసరం లేదు, నెట్ ఇవాల్యుయేషన్స్ కొన్ని తెలిసిపోయి ఉంటాయి. whoever is in the basis, their net evaluation 0 right రాసేసుకోవటం. Now most negative net evaluation, minus m by 2 plus 1, corresponding variable x2 enters the basis. Now the ratios would be 5 by 2 10, 21 by 2 6, this is 2. Luckily here one after the other it is leaving by default by using the procedure only. Okay, so artificial variable 2 is leaving the basis. The intersection of entering and leaving the basis is the pivot element half. Make half as 1 and rest of the elements in that column as 0. That column as 0. అడుగమ్మా అడుగు అడుగు, ఏం కాదు, ఏం లేదా? ఓకే, క్యాలిక్యులేట్ చేస్తున్నాను. గుడ్. ఏమైనా డౌట్స్ ఉంటే అడగండి, ఓకేనా? డోంట్ హెజిటేట్ టు ఆస్క్ ఏ క్వశ్చన్ ఇన్ దీస్ కైండ్ ఆఫ్ క్వశ్చన్స్ ఎస్పెషల్లీ. ఓకే, 1 అంటే ఇది 0, హాఫ్ అంటే ఇది 2, a2 పోయి x2 వచ్చాడు, x2 అంటే ఇటు -3 వస్తుంది, s2 0, -4 x1. ఓకే, 1 1 0 -2. Again a2 entries I stop compiling them, computing them, therefore వీడు కూడా రాడిక. Okay, now see what happens. Just subtraction 1, subtraction 4, subtraction -1 0 1, -7 times and add, -7 times and add, -7 times and add, -7 times and add, -7 times and add. Okay, delta J, Zj minus Cj. x1 ఉన్నాడు, x2 ఉన్నాడు, s2 ఉన్నాడు, వీళ్ళందరూ జీరోస్. సో ఇప్పుడు 4 -3 1 1, వీడు -4 plus 6 2, optimality reached. S1 ఇదా 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 5 - 1 కదా, నేను దీంట్లోంచి తీసా, కరెక్టే, దీంట్లోంచి డైరెక్ట్ తీసేసా, హాఫే కదా, హాఫ్ మైనస్ హాఫ్, 1 - 1 5 - 1 4, కరెక్టే. అంటే మీరు ఓన్గా చేయండి, నన్ను చూసి చేయకండి. మీరు ఓన్గా చేసుకున్నప్పుడు నేను చేసింది తప్పు అనిపిస్తే ఐడెంటిఫై చేయండి, వెంటనే చెప్పండి. ఓకేనా? కరెక్టేనా? ఆప్టిమాలిటీ రీచ్డ్ ఆర్ నాట్? ఒకసారి చెక్ చేసుకుంటున్నాను. సరిపోయింది. Optimality is reached because all net evaluations are non-negative. Okay. Therefore, final answer is x1 equal to 4, x2 equal to 2. This is for z star. Therefore, z equal to, substitute directly here, 4, 4, 16, 16 plus 6. 16 plus 6 and 22. Z star is minus 22, whereas Z is plus 22. Good question. Off late, UPSC just started asking these questions. All these years, there is no question like this. No artificial variable techniques. Always it is direct, less than or equal to so on. All less than or equal to questions they were asking. But off late, they just started asking these questions. But you should be very good at these questions, I'm telling you. You cannot leave these questions. Already my syllabus is takku indullo. Andullo kuda selective ante kastam. Okay, next question. Use big M method to solve. Use big M method to solve. Maximize z equal to 6x1 plus 4x2 subjected to constraints 2x1 plus 3x2 less than or equal to 30, 3x1 plus 2x2 less than or equal to 24, x1 plus x2 greater than or equal to 3, x1 comma x2 greater than or equal to 0. Continue the question. Is the solution unique? Is the solution unique? If not, give two different solutions. If not, give two different solutions. Sir, immediately. X1 equal to 8, x2 equal to 0. After second iteration, x1 equal to 8, x2 equal to 0. Is there alternate solution? Yes, you have an alternate solution. In fact, the question itself is saying, giving some hint on that. Is it only optimal solution? There is an alternate solution actually. How do you know that there is an alternate solution? Net evaluation of non-basis variable is 0 at optimality. At optimality. What is that? x2. Okay. So, x2 is 0, net evaluation at optimality. Therefore, get an alternate solution also. An alternate solution being x1 equal to 12 by 5, x2 equal to 42 by 5, obviously z comes out to be 48. Okay. Which answers the second part of the question. Take some more questions for your practice. Use big M method to solve. Use big M method to solve. Maximize z equal to x1 plus x2 plus x4 subjected to the constraints x1 plus x2 plus x3 plus x4 equal to 4 x1 plus 2x2 plus x3 plus x5 equal to 4, x1 plus 2x2 plus x3 equal to 4, all xi is greater than or equal to 0. If it has to be only putting in the standard form, it's already in the standard form. So in order to apply simplex method, we need to get initial basic feasible solution, for which you may require to introduce artificial variables. How many? 1. So you treat x4 and x5 as slack variables only, and then introduce only one artificial variable. Don't introduce 3 artificial variables. Are you getting? Don't introduce 3 artificial variables, which may lengthen your answer. Okay, fine. x4, x5 basis. x4 equal to 4, x5 equal to 4, a1 equal to 4 also will be part of basis. వస్తుంది, వచ్చి తీరాలి, అదే రూల్. వచ్చి basis variables, all its net evaluations have to be 0 at any cost. Doubt లేదు, అది basic rule of the game. అది ఏం చేస్తాం? x1 బేసిస్ లో పెడదామా? s1 ఏది? ఎందుకు x4 you consider as slack variable, x5 also consider as slack variable. ఇక్కడ ప్లస్ s1 ఏంటి? స్లాక్ వేరియబుల్ ఎప్పుడు వస్తుంది? లెస్ దాన్ ఆర్ ఈక్వల్ టు ఉన్నప్పుడు వస్తుంది. అవునా? స్లాక్ వేరియబుల్ లెస్ దాన్ ఆర్ ఈక్వల్ టు ఉన్నప్పుడు, మైనస్ సర్ప్లస్ వేరియబుల్ గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు ఉన్నప్పుడు మాత్రమే వస్తాయి అవి. అంతేనా? ఇనిషియల్ బేసిక్ ఫీజిబుల్ సొల్యూషన్ ప్రాబ్లం వచ్చినప్పుడు ఆర్టిఫిషియల్ వేరియబుల్ వస్తుంది. సో ఇక్కడ మనకు రావాల్సిన ఆర్టిఫిషియల్ వేరియబుల్ తప్ప ఇంకో ఛాన్స్ లేదు. అంతేనా? స్లాక్ వేరియబుల్ రాదు అక్కడ. ఎక్కడ? సపోజ్ x2 అండ్ x3 స్లాక్ వేరియబుల్. నేను ఆ సినారియో ఇస్తాను, x2 x3 కూడానా? నీకు ఎలా ఉందో అలా రాసుకో. నీకు ఐడెంటిటీ మ్యాట్రిక్స్ అని ఎందుకు చెప్పానంటే, ఇది స్లాక్ వేరియబుల్స్ ఐడెంటిటీలోకి వస్తాయని. See, simplex method is not just to find a solution like this. It can even give inverse of a matrix. You can find inverse of a matrix by using simplex method. You can find even solve solution of simultaneous equations. Remember linear algebra, we solved solutions of simultaneous equations. That also I can get by using simplex method. అక్కడ అప్లికేషన్స్ వస్తాయి. అప్లికేషన్స్లో అక్కడ ఐడెంటిటీ మ్యాట్రిక్స్ ఉండటం ఇంపార్టెంట్. మనకి పక్కనే రాసుకుంటే దీని సొల్యూషన్ అక్కడ కనబడుతుంది ఇన్వర్స్. లేదనుకోండి, ఇష్టమైన రాసుకున్నాం అనుకోండి. మన టెండెన్సీ ఎట్లుంటుందంటే, ఒక సిస్టమేటిక్గా వెళ్తే ఎప్పుడైనా కానీ, దెన్ థింగ్స్ బికమ్ ఈజీ. టుమారో ఇఫ్ యూ వాంట్ టు లెర్న్ అడిషనల్ థింగ్స్ ఆల్సో, యూ కెన్ ఆల్వేస్ లెర్న్. Assuming that tomorrow UPSC suddenly has given find inverse of a matrix by using simplex method అన్నాడు. అది అడగడు, మా టైం క్వశ్చన్ అదంతా, మీ టైంలో క్వశ్చన్ కాదు. ఓకే, దెన్ యూ షుడ్ నో లైక్ వీ హ్యావ్ టు ఫార్మ్ ఏ కైండ్ ఆఫ్ ఐడెంటిటీ మ్యాట్రిక్స్ దేర్. అట్లా అండర్స్టూడ్ ఈ క్వశ్చన్? అర్థం కాలేదా? అర్థమైందా? ఆన్సర్ కావాలా? x1 equal to x3 equal to 0, x2 equal to x4 equal to 2, therefore z equal to 4. There exists an alternate solution. There exists an alternate solution which would be x1 equal to 4, therefore z equal to 4. Take this question. Maximize. In fact, I am trying to give you different scenarios here. Okay. So before giving homework, if I give you certain miscellaneous questions, and all these questions never ever appeared, not never, my time they appeared, but not in your case. Okay. But still you should know like how to simplify a question. Okay. Generally the tendency of any student is, since equality is there, they try to find initial basic feasible solution by introducing 3 artificial variables. Which is unnecessary, unless you are trying to complicate the things. Okay, fine. Next question. Maximize z equal to 3x1 plus 2x2 subjected to the constraints 2x1 plus x2 less than or equal to 2, 3x1 plus 4x2 greater than or equal to 12, x1 comma x2 greater than or equal to 0. ఒక్కసారి చేసి చూడండి. Make it fast. In one iteration, no feasible solution because of the reason that optimality is reached, but still artificial variable exists in the basis, right? Scenario. So you just need to mention there that there exists no feasible solution because of the reason, whatever the reason. Take some questions for your homework. Minimize z equal to 2x1 plus x2 subjected to the constraints 3x1 plus x2 equal to 3, 4x1 plus 3x2 greater than or equal to 6, x1 plus 2x2 less than or equal to 3, x1 comma x2 greater than or equal to 0. Now here is the place where in this question you will get a case of degeneracy. Degeneracy means you will get the same minimum ratio. So which variable has to leave the basis, you will get a degeneracy. The degeneracy is actually between the artificial variable and a regular variable. So obviously you are going to throw out your artificial variable. Okay. Answer comes as x1 equal to 3 by 5, x2 equal to 6 by 5, z equal to 12 by 5. Take one more question. Maximize z equal to x1 plus 2x2 plus 3x3 minus x4 subjected to the constraints x1 plus 2x2 plus 3x3 equal to 15, 2x1 plus x2 plus 5x3 equal to 20, x1 plus 2x2 plus x3 plus x4 equal to 10. Answer comes as x1 equal to x2 equal to x3 equal to 5 by 2, z equal to 15. I think there exists alternate solution for that question, if I am not wrong. Take one last question here. Maximize z equal to 3x1 plus 2x2 plus x3 subjected to the constraints 2x1 plus 5x2 plus x3 equal to 12. 3x1 plus 4x2 equal to 11. x2 comma x3 greater than or equal to 0. x1 is unrestricted in sign. Answer comes as x1 equal to 11 by 3, x2 is 0, x through 14 by 3, z equal to 47 by 3. Two-phase method. Two-phase method. Okay. So as the name suggests, two-phase method, two phases, phase 1 and phase 2. So what happens in both the phases, phase 1 and phase 2? In phase 1, what we do is, we construct a objective function z star which contains zero cost coefficients to all the variables except artificial variables, for which we give -1 cost. So whatever variables that we have, of course it has to be maximization problem, quite obviously. 0 times of x1, 0 times of x2, so and so, plus 0 times of s1, plus 0 times of s2, so and so, minus a1 or minus a2, whatever number of artificial variables that exist. So phase 1, what we do is, we assign 0 cost to all the variables except artificial variables, for which we assign -1 cost. So apply simplex method. When optimality is reached, this is delta j. When optimality is reached, artificial variable goes out of the basis, then only optimality can be reached for the phase 1. Optimality for the phase 1 is when artificial variable leaves the basis. Till that time you cannot get optimality, right? When optimality is reached, what happens? All the artificial variable goes out of the basis. So their entries I will not be computing anyway. And the cost coefficients of all the variables is 0. So cost coefficients of all the variables is 0 only, right? Other variables. So here also you will get 0. That means all the net evaluations also comes out to be 0. In the phase 1. The phase 1, when all artificial variables leave the basis, with this objective function, when all the artificial variables leave the basis, then the deltas j's you will get zeros. All net evaluation come out to it. This is the end of phase 1 because all delta j's are non-negative. They are not negative. Equal to 0 is okay. Non-negative. They are not negative. Okay. So delta j's are greater than or equal to 0. Therefore, optimality is reached. This is the end of phase 1. Then what would be phase 2 then? Whatever is the solution space that I have here, this is solution space of phase 1. That solution space I will consider with original objective function. With original objective function. That means my z it comes into picture now. Till that time z will not come into picture. Z will come into picture. The original objective function comes into picture only with the beginning of phase 1. Till the time it is a z star objective function for which all cost coefficients of all the variables are zeros except for artificial variables. For artificial variables, what I do? I give -1 cost and then use simplex method. When artificial variable leave the basis, then optimality is reached. Sometimes here itself it so happens that optimality is reached, but artificial variable still exists in the basis. So no feasible solution again. So whenever at optimality artificial variable exists in the basis, there is no feasible solution for that. Okay? Fine. Assuming that optimality is reached. When optimality is reached, all zero net evaluations, you will get a solution space here that becomes your initial basic feasible solution for phase 1, for which the original objective function comes into picture. Original objective function means what? Original objective function means the cost coefficients, original cost coefficients of all the variables. Right? Original cost coefficients of whatever, maybe C1, C2, C3, whatever are there. The original cost coefficients come. Then again use simplex method, finally get optimal. That is phase 2. Take some notes. Phase 1. Phase 1. Understood? Okay? You understand objective function when you change it. In the previous method, became method, there is no two phases there. It's only one single phase in which you assign minus m cost to all the artificial variables in the original objective function only. Okay? Phase 1. Assign minus 1 cost, assign minus 1 cost to all artificial variables. Assign minus 1 cost to all artificial variables and 0 cost, number 0, 0 cost to all other variables in the objective function. 0 cost to all other variables in the objective function. Use simplex method to obtain optimality. To obtain optimality. Next, phase 2. Phase 2. Use optimum feasible solution of phase 1 as starting solution of phase 2 with original objective function. With original objective function, that is original cost to all the variables. Original cost to all the variables. Of course, here there are no artificial variables. All of it, artificial variables already left the basis. Phase 1 ends means artificial variable is already gone. So in phase 2, there is no artificial variable as such. Okay? Fine. And use simplex method to obtain optimality. Continue with simplex method to obtain optimality. Just take a note there, note. Remove artificial variables before initiating phase 2. Remove artificial variables before initiating phase 2. Next. Take a question. Use two-phase method. Use two-phase method to solve maximize z equal to 2x1 plus x2 plus x3. subjected to the constraints 4x1 plus 6x2 plus 3x3 less than or equal to 8, 3x1 minus 6x2 minus 4x3 less than or equal to 1, 2x1 plus 3x2 minus 5x3 greater than or equal to 4, x1 comma x2 comma x3 greater than or equal to 0. Okay. Fine. So what we'll do now? Phase 1. Start phase 1. Before starting phase 1, first we have to put this in the standard form. Okay. So putting the given LPP in the standard form. So objective function, leave it alone as of now. Okay, because objective function keeps changing depending upon the phases, depending on method that you use and the phases also. So coming to this one, conditions 4x1 plus 6x2 plus 3x3 plus s1 equal to 8, 3x1 minus 6x2 minus 4x3 plus s2 equal to 1, 2x1 plus 3x2 minus 5x3 minus s2 plus s3, minus s3 plus a1 equal to 4, x1, x2, x3, s1, s2, s3, a1 all non-negative. So artificial variable exists, therefore we use two-phase method. So phase 1, let z star equal to 0 times of x1 plus 0 times of x2 plus 0 times of x3 plus 0 times of s1 plus 0 times of s2 plus 0 times of s3 minus a1. Or you can mention, let the objective function be z star equal to so and so and so, which is obtained by giving 0 cost to all the variables and minus 1 cost to the artificial variables. Form the simplex table. S1 8, S2 1, A1 4, 0 0 0 0 0 0 minus 1, 0 0 minus 1, 4 6 3 1 0 0 0, 3 minus 6 minus 4 0 1 0 0, 2 3 minus 5 0 0 minus 1 and 1. Delta j equal to zj minus cj. So minus 2, minus 3, 5, 0, 0, 1, minus 1. Zero. ratios first. Before that, what is most negative net evaluation? Minus 3, corresponding variable x2 enters the basis. Ratios 4 by 3 and 4 by 3. Which one leaves the basis? A1. Question of degeneracy. Emma, question of degeneracy between A1 and S1. So A1 leaves the basis. Once it is leaving the basis, you got answer. Solution of phase 1. So S1, S2, A1 goes and X2 enters 0, 0, 0. So key element is 3, 0, 0, 1, 0, 2 by 3, 4 by 3, minus 5 by 3, 0, 0, minus 1 by 3. I will not give entries for artificial variable. Fatafat cheseddam agandi. Ippudu 0 cheyali kada. 2 times 2 times 2 times 2 times 15 minus 14, 2 times 2 times 2 times, minus 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 2 times. చిన్నప్పుడు మా ఊర్లో మా పంతులు గారు ఉండేవాళ్ళు. పంతులు గారు అంటే బడ్డీ కొట్లు ఉంటాయి, తెలుసా మీకు? బడ్డీ కొట్లు ఊర్లలో బడ్డీ కొట్లు అని ఉంటాయి. రేషన్ షాపులు ఉంటాయి చూస్తే అయ్యే బడ్డీ కొట్లు అంటాం. రేషన్ షాప్ పంతులు గారు ఉంటారు. కాళ్ళ మీద కాలు వేసుకొని పీట పెట్టుకొని లెక్కలేస్తూ ఉంటాడు. అంటాడు. అలా వేసుకోవాలి లెక్కలు. సరే, సో ఆబ్వియస్లీ అన్ని జీరోలు వస్తాయి. ఏం చేసుకున్నా జీరోలే రావాలి. అన్ని మల్టిప్లికేషన్ జీరోస్తోనే కదా. Now, artificial variable left the basis, therefore optimality is reached immediately. So as soon as all artificial variables leave the basis, optimality of phase 1 optimality is reached. Okay, you will write that. Next. So what happens now? This box becomes initial basic feasible solution for phase 2 with original objective function. Okay? Next, phase 2. Consider optimal solution of phase 1. Optimal solution of phase 1 as initial basic feasible solution of phase 2 with original objective function. That is assigning original cos to all variables x1, x2, x3, s1, s2, s3. What are original cos? 2, 1, 1, 0, 0, 0. S1 equal to 0, S2 equal to 9, x2 equal to 4 by 3. So 0, 0, 13, 1, 0, 2, 7, 0, minus 14, 0, 1, minus 2, 2 by 3, 1, minus 5 by 3, 0, 0, minus 1 by 3. So 0, 0, x2, 1. So delta j equal to zj minus cj. So 2 by 3 minus 2, minus 6 minus 4 by 3, x2 0. minus 5 by 3 minus 1 minus 8 by 3 s1 0 s2 0 s3 minus 1 by 3. So which one enters the basis? x3. Which one leaves the basis? Choice లేదు మనకి, చాయిస్ లేదు. ఎందుకు? ఈ రెండు నెగిటివ్ వచ్చేసినాయి కాబట్టి రేషియోలో ఒకటే వస్తుంది రేషియో. సో 13 becomes key element or pi-it element, making it as 1 by using elementary row operations. 0, so 0 0 0 x3 1 0 s2 1 x2 1 by 13 0 2 by 13. కొద్దిగా కేర్ఫుల్గా క్యాలిక్యులేట్ చేయాలి ఎంట్రీస్. మీరు ఓన్గా చేయండి, నా వాల్యూస్ తీసుకోవద్దు. నావి తప్పు ఉండే అవకాశం ఉంది. ఎప్పుడో చిన్నప్పుడు చేసిన క్వశ్చన్లు ఇవి. సరే, ఓకే. ఎనీవన్ హూ గాట్ ఆన్సర్? వచ్చినా? ఓకే, ఫైన్. So x1 is 9 by 7, x2 is 10 by 21, x3 is 0, z equal to 64 by 21. వచ్చింది ఎవరికన్నా? వెరీ గుడ్. ఆ 13 చూసే భయపడిపోతాం మామూలుగా కదా. అండ్ డోంట్ యూజ్ క్యాలిక్యులేటర్. పొరపాటున మీ క్యాలిక్యులేటర్ మీ పక్కన ఉంది కదా అని చెప్పి 13 చూసి భయపడిపోయి క్యాలిక్యులేటర్ యూజ్ చేశారా, ఇంక ఎగిరిపోయినట్టు, ఎగ్జామ్ వెళ్ళినట్టు. బికాస్ డివైడింగ్ విత్ 13 మీకు చాలా ట్రబుల్ ఇస్తుంది క్యాలిక్యులేటర్, అంతే కదా. పాయింట్స్లో వస్తుంది. బికాస్ ఆల్వేస్ దిస్ రో ఆపరేషన్స్ షుడ్ బి వెరీ 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 సింపుల్ ఇఫ్ యూ కీప్ రేషియోస్ యాజ్ రేషియోస్ ఓన్లీ. ఫర్ ఎగ్జాంపుల్ ఇందాకే చేసాం కదా ఈ 1/3లు, put ratios as ratios only, don't put them as decimal digits. Calculator always gives decimal digits kada. Okay, take this question, take some more questions for your homework. Chala unnayante. Use two-phase simplex method to minimize. Z equal to x1 plus x2 plus x3 subjected to constraints x1 minus 3x2 plus 4x3 equal to 5, x1 minus 2x2 less than or equal to 3, 2x2 minus x3 greater than or equal to 4, x1 comma x2 greater than or equal to 0, and x3 is unrestricted in sign. చేస్తారా ఇంటికి వెళ్ళి? డౌట్స్ ఏమైనా ఉన్నాయా? ఆ క్వశ్చన్ చేస్తారు కలిసిపోయి, ఇంకేం డౌట్లు వస్తాయి. అప్పుడప్పుడు మ్యాథ్స్లో నేను ఒక టెక్నిక్ ఫాలో అవుతూ ఉంటాను. నాకు ఎప్పుడన్నా అలసిపోయానని ఫీలింగ్ వచ్చింది అనుకోండి, అలాంటి క్వశ్చన్ ఒకటి ఇచ్చి వెళ్ళిపోతా బయటికి. కిందకెళ్ళి హాయిగా వచ్చి ఛాయ్ తాగేసి వస్తా. ఇది ఓడీలో బాగా పనిచేస్తుంది. ఓడీలో బికాస్ ఐ కెన్ గివ్ సమ్ 3-4 questions ఆన్ బోర్డ్ అండ్ గో అవుట్. ఎవరిని వచ్చారు ఇంకో కౌన్సిలింగ్ చేసుకొని మళ్ళీ రావచ్చు. ఓకే, టేక్ దిస్ ఆన్సర్. ఏమన్సర్ ఇది? x1. x1 equal to x2 equal to 21/5, x3 equal to 22/5, z equal to 43/5. Okay. Two-phase method kada. Take some more questions. Maximize z equal to 5x1 plus 3x2 subjected to constraints 2x1 plus x2 less than or equal to 1, x1 plus 4x2 greater than or equal to 6, x1 comma x2 greater than or equal to 0. No feasible solution. Maximize z equal to 5x1 minus 4x2 plus 3x3 subjected to constraints 2x1 plus x2 minus 6x3 equal to 20, 6x1 plus 5x2 plus 10x3 less than or equal to 76, 8x1 minus 3x2 plus 6x3 less than or equal to 50, x1 comma x2 comma x3 greater than or equal to 0. So x1 is 55/7, x2 is 30/7, x3 is 0, z is 155/7. Enough homework idanta. ఈ మాత్రం చేయగలిగితే చాలు. And obviously you will be doing all the previous question papers for sure. Some more. Maximize z equal to 3x1 plus 2x2 subjected to the constraints 2x1 plus x2 less than or equal to 2, 3x1 plus 4x2 greater than or equal to 12, x1 comma x1. What I also suggest you to do is, whenever there are only two variables, two decision variables, try to do it in graphical also and see what happens, from where it goes to where, and then try to see that. Simplex method as well as graphical method, both of them, try to compare them. Okay, you will get some ideas. So no feasible solution. Maximize z equal to 2x1 plus 3x2 plus 5x3 subjected to constraints 3x1 plus 10x2 plus 5x3 less than or equal to 15, 33x1 minus 10x2 plus 9x3 less than or equal to 33, x1 plus 2x2 plus x3 greater than or equal to 4, x1 comma x2 comma x3 greater than or equal to 0. Again, no feasible solution. I don't know, maybe I would have selected only no feasible solution kind of questions, but actually most of these are not feasible or not. Okay, take some more questions. Oral, some more questions. Maximize z equal to 5x1 plus 3x2. See, this is done with this two phase also. I am giving some more questions which I have seen. So it's just a small collection, very small collection. Subjected to conditions x1 plus x2 less than or equal to 2, 5x1 plus 2x2 less than or equal to 10, 3x1 plus 8x2 less than or equal to 12. Now that is, there are certain instances where you might get degeneracy in regular questions also. So all those questions, how you would solve, that is important. So whether you can use a rule or you can use your common sense or you can use by default whatever in the case of degeneracy, you try to use it and get an answer. x1 equal to 2, x2 equal to, ఇది చేసినట్టు అనిపిస్తుంది ఈ క్వశ్చన్ ఎందుకో. సరే. So one more question. Maximize z equal to 2x1 plus x2 subjected to constraints 4x1 plus 3x2 less than or equal to 12, 4x1 plus x2 less than or equal to 8, 4x1 minus x2 less than or equal to 8, x1 minus x2 less than or equal to 0. Answer x1 equal to 3 by 2, x2 equal to 2, z equal to 5. Okay. That's it. We can move. Tomorrow we'll go with the transportation problem and assignment problem.